You can see the link here. I will also share it in the uh, Google Drive. There is another resource which is very useful resource. So Dr. Colonel Iqbal. So Dr. Colonel Iqbal is a retired colonel from uh, Dr. CM Iqbal. Sorry, you have to write Dr. CM Iqbal. He is a retired colonel from Army Engineering Corps, and he is an NHA expert in bridges. So he has also spent a lot of time in National Highway, and he is their bridges expert. So this is his website. Hope my screen is visible to you guys. Do you guys see my screen? Please response. Please give me response.
Yes, yes, we can see.
Okay. So this is his website. You can see that it has a lot of resources. So pre-stress girder bridges. So these are some of the design that he has done. He has shared it with the public. So these are up to 44-meter length. He has shared the drawings. So you can download the drawings from here. You click here and you will download it. Similarly, box culverts, retaining walls, RC retaining walls, and RC girder bridges. So he also has. Uh, there is a problem with these drawings. Sometimes they do not open in Adobe Acrobat. So what you have to do, you have to open it with Microsoft Edge, so they will open them. So for example, if I want to open them in Adobe Acrobat, so they will give me this error. I don't know what is the problem with these drawings, but if I want to open it in Microsoft Edge, it will open. So now it works. You see, now it works. It does not work in Adobe Acrobat, but works in Microsoft Edge. So it is a typical T-beam design he has shared with the public. Let me close the WhatsApp, so it is disturbing me again and again. Okay. Now coming toward the software. So as I told you guys that when we start a new model, so we have two options: start from initialize from existing model. Hope you guys got this. The purpose of this. If someone has any problem, they can ask. Otherwise, I think it is self-explanatory. Okay. If you don't have any model and you want to create a new model from scratch, so this is the option you have to select. So default units. So you have to select any units that you are using. Mostly we use the SI unit, SI units and bridges in Pakistan. Mostly SI units are using the bridges. So I will select Newton meter, United States. You have to select the preferred country, or it is not a, mostly we are using is ASTO, so I am selecting United States. Okay, so these are the templates that are available in the CSI bridge. For example, this is a segmental bridge. So if I showed you a video in the previous class about the segmental construction. So in the segmental construction, let me show what is segmental construction. So segmental construction is different from the conventional RC bridges or precess bridges. So in the segmental construction, what is done? You can see images. So okay, this picture is quite a good picture for segmental construction. So you see in the segmental construction, we construct this pair. After constructing the pairs, this type of construction technique is used for long span bridges, and when you don't want to disturb uh, the existing traffic, so you have to use such type of construction. If in Pakistan it is not very developed, so it has been used in the Khairabad bridge, and 5-6 bridges are built with this technique, but mostly we use the conventional technique. If this was famous or it was frequently used in Pakistan, so we wouldn't have to face such problems just like we face in the BRT construction, that the whole road was disturbed and we have to use single road, and for 2-3 years the people were their life was disturbed so much. if like in Pakistan this type of construction technology was developed. So in the segmental construction, these piers are built. Then these first two sections, first three sections, they are known as pier tables or pier heads. So they are constructed by placing a formwork here. After the construction of these portions, this formwork, which is known as gantry or movable formwork, is placed on above these spearheads. So they are at these gantries, what we do that these gantries have formers for these box sections. So you can see that these are small segments jointed together. So now after placing this gantry, a segment is constructed here at the left and at the right, and then the section are stressed. Some these structures are mostly pre-stressed, they are not conventional RC structures. So in this way the construction proceeds forwards. So it also has multiple types of techniques. One is the balance cantilevering. So this is basically a balance cantilever type of structure. So a cantilever is proceeded from the piers. This is another technique which is known as span by span construction. So a span is constructed and another span is proceeded after the previous span. But you can see in this structure we do not interfere with um, the environment below the bridge. So this is a very good technique for construction of bridges, but unfortunately not very common in Pakistan due to the wrong practices. Or you can see, uh, I don't want to go into detail why people do not go for such type of bridges. Uh, So this is the segmental. So you can perform segmental analysis as well. Suspension, it has an inbuilt suspension. You can model suspension bridges with CSI bridge as well, but you can model it without the template as well. If you do not select the template, you can model them without. So, it also has a template for cable stayed bridges. So we will mostly discuss RC bridge in this course. This is Caltron BAG. Caltron B. This template is used for seismic, non-linear seismic analysis of bridges, and Caltrans is basically California Transportation Department. So Caltrans has done a lot of research in the bridges, so they also have their own version of code. So, and in the seismic design, we mostly use their recommendations. So for seismic design of or non-linear design or for research purpose, we use this Caltron template. These are the common template available in SAP. If someone of you is have done work in SAP, so they might have seen these template as well, beam, truss, and uh, these are all the common templates available in CSI bridge. So if you have a very common bridge and a very not an extraordinary spans, and it does not have any extraordinary geometry, so you can start with the quick bridge as well. So when you select the quick bridge, it will ask from you about the layout line. So for example, for basic, for straight spans or for very short span bridges, or for example, if you have a section that is available, a section available in the codes, or it has a predefined section available in CSI bridge, so you can use this template as well. So for example, I have a 30-meter bridge, and it is a box girder bridge, a straight span. So I will select the station. So start station or start abutment, initial bearing 90 east. I will explain you tomorrow what does this mean. So initial bearing 90 east mean that this is the quadrantial bearing system. So north, south. Sorry, I don't have any pad, so I'm using mouse. This is east and this is west. So 90 east means this is 90 east. So it will go in this direction. Hope you guys got it. So this will be the direction, initial direction of the bridge. So start station will be 0. Grade will be 0. It is a straight bridge, so it does not have any super grade change. It is a straight bridge. Radius is 0. As I said previously, it is a straight bridge. Super elevation is 0. Everything is default. Span length 20. Okay. I am selecting this predefined section. Abutments typical. Keep all the things as it is and click OK. It is updating. Okay, so this is, it will, if you have a typical type of bridge, it will uh, create a bridge in within minutes for you. If you have default templates, or if you have a bridge structure that have section available pretty, so it is a box type bridge which is a post tension. So you can see here it has a post tension duct, a post tension tendon as well. So this is a typical line model or a spine model. This type of model in which the superstructure is modeled as a single element. You see a single element, so only a single beam is used to model the superstructure. This is known as spine model. Let me extrude this. So I extrude, this is a standard view, and extrude view we can see the 3D view. So I will apply the extrude view. So you see this is an extrude view of this bridge. So this is a 3-cell box girder bridge, typical section which is available. So you can very easily model this if you have typical section available, a bridge that is to be modeled with the typical section. So this is how you can very easily model a bridge with predefined section. So we do not use this quick bridge most of our time because we don't have a typical section that are available, because we do not use here in Pakistan American section. We use our own sections, so therefore we don't use this quick bridge template. We most of the time use it from the scratch. So how we do this? Let me do it again from the start. So what we do, we select this blank option. So in the blank option, you have to do everything from your own. So yesterday we discussed that the bridge has 3 components: superstructure, bearings, and substructures. So if you see the tabs here, they are designed in such a way that if you go from one by one through in order from these tab to the end tab, you will automatically perform a complete design of a bridge. So if the first you have to start from the home, then layout, then components, then loads, then bridge, then analysis, then design. So if you go in this order and complete everything available in these tabs, so when you come to analysis, you would have modeled a complete bridge. So okay. But today I will show you the bridge wizard. The bridge wizard is a very unique option in CSI bridge, and it is for the user who are not very frequent with bridge design. So they have given this option, bridge wizard. So in the bridge wizard, this wizard will guide you with every step that you perform in the design or in the modeling of bridge. So I have prepared this lecture on the bridge wizard as well. So I will give this lecture to you guys. You can check it yourself. I will explain in this video how, in this lecture, how we use the bridge wizard. Uh, I have defined or explained every step that we use in the bridge wizard in this presentation as well. So the bridge wizard is for those user who are not very uh, seasoned in bridge design. So this bridge wizard is a very powerful tool. So for example, so when you start from this step number 1, 2, 3, 4, and perform everything that is done in these steps, so you will, at the end of these steps, you will have completely designed a bridge, if you know what is being asked from you in this bridge wizard. So when you click any option on this, so it will in detail show you what is required from you, from what we have to done in this tab. So in the step number 1, this is the introduction of the bridge wizard. What is the bridge wizard about? So the bridge wizard is basically a wizard which guide you toward a complete model of modeling a complete bridge. So it has two sections: a summary table and the currently defined table. So for example, layout line. So one thing more, all those things which are necessary for a typical bridge, they are not in their note section, they are referred to as required. So all the required sections, you must have to model, define them here for the complete bridge modeling. The advanced are not required in every bridge, so they have labeled it as advanced. But the major things or the major components of a bridge model that are necessary for any bridge, you have to you have to perform them, and they will be referred to as required. So the first thing is layout line. So when you select layout line, this tab will show will appear here. At introduction, it does not have anything here. When you select layout line, so this will appear. So layout line is basically the line along which your bridge will go. So for example, if you have a straight bridge, so you will define a straight layout line. Tomorrow our lecture will be about this layout line. So we will discuss in detail what a layout line is. So you can consider the layout line as same as we draw layouts in building construction. For example, if you want to construct a building, so what is the first step? The surveyor come to the site and he lays some marking on the ground, and then the excavation is done on those markings. So the layout lines serve the same purpose. So when you define the layout line, so the geometry of the layout line, the direction of the layout line will serve will be this, will provide a guide to the bridge. So your bridge will the bridge will have the same geometry or the same curvature and the same elevation and the same grade, which is the which you have defined in the layout line. So this is we will discuss tomorrow in detail, inshallah, what this layout line is. This is just to show you how you can perform design. So by going stepwise through this bridge wizard. So for example, I have by default it has these values, so I will leave it to the default, and the end station is 30. So the start station is 0 and the end station is 30, so the bridge length is 30 meters. So I will select OK. So I have defined a layout line. So a layout line will be defined by the bridge. So as I define a layout line, here the type will change. BLL1 is the layout line that I have defined now. You can see the layout line that I have defined now. Modify show line, so I can change its name to layout 1. Okay, after defining layout line, the next thing is materials. So you have in bridges we have material for superstructure, for substructure. So it is marked as required, so you have to define material as well. So define material. So for example, these are the predefined material: 4000 psi concrete, A701 grade 50 steel. So I define a add new material. I will define rebar. So rebar ASTM 615, we typically use ASTM 615. 706 is not used in bridges. Grade 60, so I will select grade 60. So it will define a material for me by a grade 60. This is a grade 60 steel. So as I select this, this will appear in the material. So these material will come. Now after materials, this is links. So link is not uh, required in ordinary bridges, and it is an advanced topic, so it does not come under the scope of this course, so I will leave it. So links are basically the links between two elements, and it is a very advanced topic. So let me show you what is in the links are. You can define them for I will show you what we use links definition for. So you can define links for these restrainer elements, and these are for bearings. We also can define bearings with links, because in advanced bearings design we give our own stiffness values to bearings. So in that case you have to define your own links. We usually use the predefined or the default bearings of the CSI bridge, but for advanced bridges you have to use links, and those links you have to define yourself. So these are the different types of links you can define, and this is a very advanced topic, and we will not cover this thing in this course, because uh, it it is a separate course in itself, defining different types of non-linear links, and it also requires a good understanding of advanced mechanics of material as well. So if you have a good understanding of advanced mechanics of material and complex bridge structures, then you can define the links. So it is an advanced topic and it is not required in ordinary bridge. So we will leave as it is. The other section, the other thing is deck section. So in the deck section, you have to provide the superstructure sections. So this is also required. So these are the default templates that are available in the CSI bridge. So you can define select any of these default templates: concrete box girders, monolithic structure, for example, T-beam, flat slabs, and also we have these precast structures for precast I, precast U, steel girders. I will select just this T-beam. So leave it as it is default because we are not concerned with the actual design. So after that we define bearings. So the the step which you complete here, it appears here. Now bearings, so bearings is also required. You have to define bearings. So for example, I defined a bearing in which the bridge is fixed in all the three directions. So it cannot move either in the translation vertical, so it does not move vertically. Translation normal to layout line, it does not move longitudinally. Translation along the layout line, it does not move along the layout line longitudinally and transversely. So this is a bearing. So also I define foundation, add new foundation spring. Let me define spring, let it be, because we are not concerned with the detail, because these every single step will be discussed in the coming lecture in detail. So uh, I am just showing you how we can use the bridge wizard for bridge modeling. So abutments are, add new abutments. Okay, let leave all the defaults. Bridge object definition. So add new bridge object, journal and segmental. I will use journal. We are not using segmental. So in the bridge object, you have to define the number of spans. So I am using a single span bridge. So it is a 30. Start station is 0 and end station is 30. So this is a single span bridge. So you see this is a start station. Support is the green line shows the supports. So this is a support provided at the start and at the end. So for example, if I want to add another station, so uh, I want to add another station by length 0 to 15. Add below. So you can see another span has been defined. So I am using a single span bridge by default. So let it be. We are not discussing it in detail. We will discuss this in detail in the coming option. So all the things you have to define that are concerned with the superstructure, they are given here. So for example, if abutments you have defined there, you want to modify abutments, you can modify them from here. Similarly, the bends, so you can edit the bends from here as well. All these things you can edit: wind load, area loads, line loads, point loads. These things you can edit here as well, and you can also edit them from the tabs as well. So please do not get confused with this. The first two lectures are a little bit boring because we are not starting the actual modeling. So this is just an introduction of the bridge wizard, and we will not use bridge wizard after this lecture as well. This is just to show you that you can use this wizard. It is a very powerful tool, and it is for the new users. They can use this wizard to model the bridge from scratch. So after deck sections, all these has been defined. I will deck sections. I think I did the deck section. Abutments, bridge object definition, close wizard. So after defining the performing all of this in the bridge wizard, okay. So bridge object has been defined, deck sections. So if you have a bridge with multiple deck sections, you can change the deck section from here as well. abutments. If you have, if you have to define the abutments in detail. So in this tab, you have to define what the start abutment and the end abutment. Is there a diaphragm in the abutments? And what type of abutments you want to define? You want to define a bend type abutment, for example. If you want to provide explicitly a beam in the bridge, so you can uh, model it model it from here. Or if you want to define spring type abutment, you can use this tab. So update link model. Okay. Okay, so when you define all the parameters that are necessary for bridge definition, so in the end, what you have to do, you will be asked by the CSI bridge that what type of bridge model you want. So we have three options. We use spine model, we use area object model, and we use solid model. So in the sixth lecture, I will explain in detail when we will use spine model, when we will use area model, and when we use solid model. So for example, I use a spine model. So I showed you previously what a spine model is, that the complete structure is represented by a single line element. So you will select clear and create a linked model. Okay. So as you see, a bridge model, a single span bridges has been modeled by the CSI for me. Similarly, after you create the model, you have to define loads. So load patterns, these are the default load patterns. Let it be load cases. So after that, you will define the load cases, and these are the thing that you can do in the wizard. So and this completes the whole bridge modeling, because after load case definition, what you have to do, you just have to run the analysis option. So let me show you. You have to close this option auto update, because if you make any change in the components or any component of the bridge, it will automatically update. So it is a bit disturbing when you are doing a complex model. So you have to close this. You have to click on it, so it turns the blue, the highlighted option goes, and you have to update it manually from here. So okay, and 10 minutes, we have 10 minutes left. So as I told you that we have these three options. So now I want to update it as an area model. So in the area model, the structure will be modeled as a shell element. So the beams and the slab is modeled as a shell element. So you see, this is a shell element. So the beam is modeled as a shell element, the slab is modeled as a shell element. And the extrude view will be showed for both the same. So the extrude with a 3D view, and this is 3D view of the bridge. So it will be same for all the spine model and both area model, but the difference is between the analysis. So if you model it as an area model, so it will give you the forces for each girder separately. When you perform analysis, so let me perform analysis, a dead load analysis. For example, I perform a dead load analysis. Uh, this is a project one. So as you see, it has done analysis, has performed the analysis, and you see, so when you this option shows you the superstructure forces. So if you have done an area model, so it will show you the forces for left exterior girder, interior girder 1, interior 2, and right exterior girder. So it will show you forces for all the girders. You see, it will show you individual girder forces as well. Individual girder forces are shown by the CSI bridge if you model it as a area model. Now I am updating it as a spine model. So I update it as a spine model. Let me off the extrude view standard. So now you will see that it will show me forces only for the entire bridge section. So if you perform spine analysis, so it will not give you forces for the individual girder. And if you perform area object analysis, it will give you forces for all the girders explicitly. So this is the basic difference between the spine model and area model. And the solid model we do not use frequently for bridge design in practice, because solid model is a finite element modeling. It takes a huge amount of time for the system to analyze such type of uh, models, because it is just like, let me show you how the solid model looks like. So this is a solid model. So a solid is basically a 3D model. So it is just like if you perform analysis in Abacus or ANSYS, if some of you have used an Abacus or ANSYS, so it has divided it into a 3D object, and it will take a lot time only to perform uh, simple dead load analysis. So it does, we in design do not use the 3D solid object option. We mostly use the spine or the area object for most of our design, depending upon the bridge structure and depending upon what we are required to do. But the solid object is just used for research purpose. If you want to see the behavior of the structure, the stresses at individual or the stresses along the depth of the section. So in the design, we are not concerned with the stresses at every point. So we do not perform this solid type of modeling. Uh, I think the meeting is ending, so I will stop here. And if you guys have some question or any question, you can ask. Or let me. These are the links. Okay, so these are bearings, bearings and links. We will discuss this in the coming lectures. So uh, please do not. Uh, the first two lectures are a bit boring because it is just a theory, and when you will start the actual modeling, then you guys will enjoy it. But the first two lectures are a bit boring because they were just theory and we did not start with the actual model. From tomorrow on, we will start with actual modeling. So hope you will not feel boring in those lectures. So I think this is enough for today. I am ending the session. And if you guys have any question, so you can ask.